The idea that young blood has rejuvenating properties dates all the way back in history to ancient Greece. It was popularized in the early 19th century in European folklore, so this fascination may have been what led to a French scientist in the mid-1800s to develop the concept of parabiosis, which is the surgical suturing of two animals, namely mice, to see if they could develop a single shared circulatory system. Rejenevie has developed a human adaptation of the parabiosis concept.
The major difference between the old parabiosis model and Rejenevie's model is that we're not suturing mice together, nor are we suturing humans together. In Rejenevie's model, we're co-culturing young cells with aged cells in order to restore the immune system.
Our immune restoration technology is based on a Transwell system. This is a two-chamber system where the young cells are placed in the top chamber and the aged cells are placed in the bottom chamber. The two chambers are separated by a Transwell filter. The Transwell filter is composed of numerous nanopores. Nanopores are 400 nanometers in size.
The filter does not allow the cells to go through because they have micron size. However, smaller factors such as exosomes, microRNAs, and proteins from the young cells can go through the pores, get into the aged cells, and restore them.
Now, this whole process takes place over 7 days, and after 7 days, the aged cells are removed from the Transwell chamber, and because those pores are small enough so that the cells cannot mix, what is being given to the patient is an autologous therapy, which is just their own cells without risk of contamination from the young cells.